An architect is designing a tapered office tower where the ground floor, floor 0, is the largest and the floor space is reduced by 5% per floor. That sounds awful. If the ground floor has an area of that much, what is the area of the ninth floor? All right, so we're going to kind of create our own equation based off of like a percentage formula. Now, a typical percentage formula is y equals an initial amount times the quantity 1 plus or minus whatever rate you're talking about to the whatever power over time you're talking about. Okay, things are different here. We're not necessarily talking about a rate. We're not necessarily talking about time. And in this case, we're talking about like a building that I guess is designed like this and each floor goes up. I don't know. It's very bizarre. But as the floors go up, the areas decrease over time. So I guess that's what we're dealing with. So the equation that I'm going to use is the area that I want. So the area that I want is going to be the initial floor. So we'll call A floor 0 times 1. Since the area decreases, that's going to be minus r. So this is r as a decimal, which means 5% is 0.05. Okay, to the t power is going to be the floor. So t is going to be the floor that we're dealing with. All right, so the area that I care about is going to be the area of that 0th floor, 1140, times the quantity 1 minus r, which is that 5%, to the t power, which is the 9th floor. Very strange problem. Okay, now if I want to do a little bit more, 5% is 0.05, right? So 0.05, 1 minus 0.05 is going to be 0.95 to the 9. So this is where you're going to run your calculator and do a little bit of math. So let me do that quick. And I ended up with 718.484 blah, blah, blah. So it looks like they were rounding it to the nearest one decimal. So we'll do 718.5 meters squared. Strange problem, but we were able to use percentages to make it work anyway.